Hello, my name is Riyadh Saeed. I'm an engineer here at Agilent Technologies. RF engineers are designing next-generation transceivers to support wider bandwidth for technologies such as 802.11ac and LTE-Advanced. As you go to these wider bandwidths, amplitude flatness and phase error becomes more significant. Unfortunately, your challenge is to maintain the EVM quality and ACPR performance of your devices going forward. Unfortunately, maybe in your production line or in your verification test rack, you might have a switch matrix where you have cabling and other issues inside the test system which introduce linear amplitude and phase error. I'm excited to show you today a new feature, what we call user channel corrections, that allows you to equalize both the amplitude and phase of your test system. So next, what I'd like to do is go ahead and demonstrate that for you. So how does this system work? We have the switch matrix, our power amplifier DUT, and the spectrum analyzer. What we're going to do is take the output of the switch matrix and feed it directly to our power sensor connected to the MXG. That will then measure the amplitude and phase response of the test system. Those will be stored into a file inside the instrument as complex I plus JQ FIR filter coefficients. When you tune the instrument to any frequency, the firmware will automatically apply those filter coefficients to our real-time ASIC that applies those to your IQ waveform as they're playing. And now you will have a perfect response right out of your switch matrix. In our setup today, we have the MXG vector signal generator generating a 100 megahertz wide QPSK signal. It's then being routed into our switch matrix, which has poor match, going into an external amplifier, and then into our PXA, where we're now analyzing it with our 89600 VSA software. We also have an external USB power sensor that's plugged into the back of the MXG. We're going to be using that to actually calibrate out the linear errors of our device. So let's go ahead and take a look at that. Here we have our QPSK signal on the VSA. In the top left corner you see the QPSK constellation. The match is so bad you can't really even distinguish it. It's up to 30% EVM with this channel. If you look at the lower right-hand corner of your screen, we actually show the channel response. And you can see the log magnitude phase response. It's got plus or minus 3 to 5 dB of amplitude ripple. And in the phase response, you could see plus or minus 20 degrees of phase error across that channel bandwidth. So very poor performance. Let's go ahead and see what we can do by using the external user channel corrections. Next we want to do is correct for the amplitude and phase error that you just saw on the VSA. So we're going to take our power sensor that's connected to the MXG and connect it directly to the output of our switch matrix. So what I'm going to do is disconnect it from my power amplifier, take the power sensor and connect it directly to the output of my switch matrix. After this has been done, next thing you want to do is go to your signal generator and go ahead and actually set up the frequency range over which you want to run that calibration. So in this case I'm running at 5.25 gigahertz. I'm going to do it at that carrier frequency. You hit configure and you execute. Now that the calibration is complete, let's go ahead and disconnect our power sensor and connect it back up, connect our switch matrix back up to our power amplifier. Once that's done, let's go ahead and look at our VSA software and evaluate how well the channel correction worked for modulation quality. So now let's look at the response of the system. So I plug it back in. As you can see, it hasn't changed, and that's because we haven't applied our user channel corrections to the signal yet. So I'm just going to go to the front panel of the instrument and go ahead and turn that on. When you turn it on, you can see about 1.5 to 2% EVM performance. And the amplitude response is about plus or minus a dB, and the phase response is within plus or minus 5 degrees or less. So you've just seen our new user channel corrections equalize the amplitude and phase response of your test system. So now you can see the true performance of your device. If you'd like to find out more about the X-Series signal generators, please visit the URL on your screen. Thank you for watching.